starting on page 802, we just have the one learning target. Apply relationships between perimeters and areas of similar figures in terms of scale factor to solve problems. All right, so we're not having a new area formula. We're not finding the area of some new type of polygon or circle or any other kind of geometric figure. We're just going to, there's a nice little relationship between the scale factor of similar figures and the ratio of the areas. Remember what a scale factor is. It's a ratio made from the lengths of a pair of corresponding sides. That's what we've always called it. Well, except when we did dilations. Then we said it was the ratio of the distance from the center of dilation to a point on the new figure over the distance from the center of dilation to a corresponding point on the old figure. We're adding something to it again. Any corresponding parts of similar figures can give you the scale factor. So if you have the lengths of a pair of corresponding altitudes, that can give you the scale factor. If you know the lengths of a pair of corresponding apophthegms, that can give you the scale factor. The perimeters can give you the scale factor. Okay? So as long as it's corresponding parts, it's pretty much fair game to give you the scale factor. All right? So if we look here, so here on page 802, they remind us that if two polygons are similar, then their perimeters are proportional to the scale factor between them. In other words, the ratio of the perimeters equals the scale factor. We used that to find some perimeters back in Unit 7. Okay? Now, the ratio of the areas is a similar relationship, but not the same. The ratio of the areas doesn't equal the scale factor. The ratio of the areas equals the square of the scale factor. The ratio of the areas of two similar figures equals the scale factor squared. Okay? So you have to know that your figures are similar. You have to either be told or be given enough information to figure out what the scale factor is. And whatever the scale factor is, square it. And that equals the ratio of the areas. Okay? Now, I've written this out myself two different ways. If two polygons are similar, then the ratio of their areas is equal to the scale factor squared. But I'm more partial to the second one here. For two similar polygons, if the scale factor is A to B, and I only wrote it that way because of the, I couldn't make the fraction look right. If you want to write A over B, fine. If the scale factor is A to B, then the ratio of the areas is A squared to B squared. Okay? Because look, here's something about exponents that you knew at one point. Let me remind you. If that's the scale factor, and we say we're supposed to square it because the ratio of the areas equals the scale factor squared, that's the exact same thing as squaring the numerator and squaring the denominator. Remember that? Okay? So if the scale factor is A to B, then the ratio of the areas equals A squared to B squared. So if the scale factor is 2 to 3, then the ratio of the areas equals 2 squared to 3 squared. And we're going to use that. Okay? So I'll give you a second here to finish copying your notes that some of you are copying. Then we'll do a couple of examples. All right, page 805. Number 1. The directions say, for each pair of figures, find the area of the green figure. They tell us the area of the blue figure is 36 square yards. We're supposed to find the area of the green figure. They also tell us that the diagonal of one of those, they sure look like squares, but maybe they're not though. The diagonal of one of those quadrilaterals is 8 yards, and then the corresponding diagonal of the other one is 4 yards. So even though up until recently we've always thought of the scale factor as being the ratio of a pair of corresponding sides, in this case the scale factor is going to be the ratio of a pair of corresponding diagonals. Okay? So, and I put it here to the side. If the scale factor is a to b, then the ratio of the areas equals a squared to b squared. So let's figure out the scale factor. So the scale factor, and just be consistent when you write it. Like we've done before, I usually go left to right. So on the left, that's 8. On the right, that's 4. And then, you know, sometimes we have reduced scale factor, and sometimes we haven't bothered. It's still kind of the same thing. Almost always I'm going to reduce. Smaller numbers tend to be easier to work with. You know, sometimes there's something magic about them where that's not always the best thing to do, but that's going to be my default thing to do. So that reduces to 2 to 1, doesn't it? Now, that's our scale factor. That's a to b. So the ratio of the areas equals a squared to b squared. So look, that's a squared to b squared, isn't it? Make a ratio out of those areas and set it equal to a squared to b squared. So what is the ratio of the areas? Well, the one on the left has an area of 36. The one on the right has an area of, I don't know. So that's my variable. And I chose A because A stands for area. If you don't want to call it A, you don't have to, but I usually do because it reminds me that it's area. Okay? Then we solve it for A. Well, I know that 2 squared is 4, so when I use cross products, I get 4A equals, and I know that 1 squared is 1, so 1 times 36 is 36. Then I divide both sides by 4, and A equals 9. Now, I haven't put units on anything, but that's area. So that's what? Yards squared. Okay? Questions? All right, that's not so bad, is it? Seems like it's going to be complicated, but it's not quite so bad. So let's try number 2. All right, we're going to do the same thing here. If the scale factor is a to b, then the ratio of the areas equals a squared to b squared. So let's find the scale factor. Again, I'm going to go left over right. So 5 to 7. That doesn't reduce, does it? So that's my a to b. So the ratio of the areas equals 5 squared to 7 squared. So 5 squared to 7 squared equals the ratio of the areas. 40 to A. Okay? Now, don't assume that the unknown always winds up where I've been putting it. I'm doing it that way because I'm just sticking with left over right. Okay? They may ask us for the blue one and tell us the area of the green one. And if they did, then our A would be in the numerator instead of the denominator, wouldn't it? Okay? So don't assume it always looks just like that. Just set it up each time. All right? Well, we know that 5 squared is 25. So that'll be 25A equals. And I know that 7 squared is 49. So 49 times 40, I get 1,960. Then I divide both sides by 25. And I get 78.4, and what's the unit? Meter squared. Okay, any questions? All right, let's take a look at number 3 and number 4. All right, they've changed it up just a bit. Instead of giving us the scale factor and one area and asking us to find the other area, They're giving us both areas, but we're missing a piece of the scale factor. Okay? So it says for each pair of similar figures, use the given areas to find the scale factor from the blue to the green figure. Then find x. All right. So we're not able to figure out a to b, but I am able to figure out a squared to b squared. So since the ratio of the areas is 875 to 315, that has to equal a squared to b squared, doesn't it? Okay? Now, that means that a squared, let's see, how do I want to say this? I think the easiest way to approach it is, I've got two things in my mind conflicting. Let me check something here. 875's not a perfect square, is it? That's just weird. 875 is not a perfect square, right? 315 is not a perfect square, right? So the first thing that ran through my mind is like, well, I'll just set a squared equal to 875, and I'll know what a equals, take the square of both sides. But I'm not getting perfect squares, so let me try something different. Let me see if that 875 over 315, let's see what that reduces to. So if I do, no, not the second button. If I do 875 divided by 315, math, fraction, enter, reduces to 25/9. So now I say that a squared to b squared equals 25 to 9. And I like that better. Okay? Because now, doesn't that mean that a squared equals 25 and b squared is 9? See what I did? The numerators, if those two fractions are equal, the numerators are equal, the denominators are equal. Okay? So a equals 5, b equals 3. Well, if a equals 5 and b equals 3, then our scale factor is 5 to 3. And now that we know our scale factor is 5 to 3, we're supposed to find x. So 5 to 3 equals x to 21. Y'all following me? Okay. So that'll be 3x equals, and what's 5 times 21? And 105 divided by 3. Okay. Now, the scale factor doesn't need units, but x does. I mean, they've got them here, so x is centimeters. Now, at the risk of getting too far into the woods on radicals, let me show you something else. Okay? Y'all with me so far? Can y'all think you can work one like that?
For that, could you not just do like x over 875 and 21 over 315?
Well, they tell us to find the scale factor first. So I'm following the directions. Okay? Y'all see what he's talking about? You could do a squared to b squared equals 875 to 315, and that works, doesn't it? You got x, correct? Yeah. The only reason I worked it the way I did is they told me to find the scale factor, then find x. So I'm just following the directions. Okay? If this was a test question and all it said was find x, I like that idea better, don't you? It gets it faster. Okay? All right. Yeah, found x, then you can just work the whole problem backwards, couldn't you? Find x first, then get the scale factor. I guess really I have no problem with that. Okay. Now, let me show you something about radicals, though. You know, here we have a squared to b squared equals 875 to 315. Let me write that again. A squared to b squared equals 875 to 315. You know, when we're solving an equation, we'll get like x squared equals 25. And we say we take the square root of both sides. When I'm sitting here like this, I can take the square root of both sides, okay? And the way you take the square root of a fraction is you take the square root of the numerator over the square root of the denominator. So the square root of a squared is a, the square root of b squared is b, and then I can either do the same thing on the right, or, and here's where I'm afraid I'm getting too far into the woods on the radical, I can reduce it first, just like I did here, then, I'm running out of room on it, then take the square root of the top and the square root of the bottom and figure out what a and b equal that way. And then I've got my scale factor. Am I showing you too many different ways to work one problem? All right. It's one of those things, good news, bad news. It's good to have different ways to work a problem. Sometimes it's bad because you kind of mix and match two different methods and you don't come up with anything that's correct. You know what I'm saying? But, I mean, it works. So really, we've got basically three different ways we can do this. We can do what I did originally. We can do what I have started there in blue. Or we can do what I did originally, but solve it in a different manner like I did there in the red. Is one method the right way? Nope. Is one method always the best way? I don't think so. It depends on what the numbers are, okay? Sometimes the numbers work out really easy and sometimes they don't. All right, so far so good? All right, number 4. Same thing's going on. All right, you want to approach this one? I want to try the method I started there in blue on this one. Y'all want to try that? Okay, the ratio of the areas is 153 to 272. That equals a squared to b squared. So that equals 15 squared to x squared. Yeah. Okay, y'all with me? Does that make sense? That's not the way I worked number 3. Does that seem okay? All right, so I know that when I multiply x squared times 153, I get 153x squared. And then when I do cross products the other way, let's see, 15 squared times 272. That's attractive. 61,200. All right, let's divide both sides by 153. And I think I want to turn this, let's see what it looks like as a fraction. Fraction there. Oh, it's a whole number. That's awesome. Not only is it a whole number, it's a perfect square. So, take the square root of both sides, and x equals 20. All right, so we found the last part first. We found x. We also had to find the scale factor. So the scale factor is 15 to 20, or better yet, 3 to 4. So when you got to find a couple things, and if you're like me, you have work all over your page, not a bad idea to circle or put a box around or something, the things you're supposed to find. I think I like that method better. That was kind of easy, wasn't it? Now, it may have been easy just because the numbers worked out so nice. I don't know. But that was good. I like that. Okay, any questions? All right. All right. Again, back in Unit 7, we found out that if all corresponding angles are congruent and all corresponding sides are proportional, then two polygons are similar. For this reason, all regular polygons with the same number of sides are similar. I'm fairly confident that I said that at some point back in Unit 7, but in case I didn't, every regular pentagon is similar to every other regular pentagon. Every regular hexagon is similar to every other regular hexagon. Why would this be? Because every regular pentagon is the same shape as every other regular pentagon. Okay? Now, for this to be true, you have to say that a scale factor of 1 to 1 is okay. Because really, congruent figures are a special type of similar figures. Okay? Congruent figures are really similar figures with a scale factor of 1 to 1. But that wouldn't have been a good way to teach you congruent figures right off the bat, would it? Okay? But now you know. And last example. Zola has a picture frame that holds all of her school pictures. Isn't that sweet? Each small opening is similar to the large opening in the center. So all of those, what are those things? Octagons? They're not regular, but they're all similar to each other. If the center opening has an area of 33 square inches, what is the area of each small opening? Okay, well, since this side right here is 1.2 inches, and then the corresponding side of the bigger figure is 3 inches, isn't the scale factor 1.2 to 3? Now, that's going small to large, okay? So, the ratio of the areas. Now, I got to write it small to large, okay? So, small, I don't know, to large, they tell us is 33. That's going to equal a squared to b squared. So, that's going to equal 1.2 squared to 3 squared. Does that seem reasonable? When you're dealing with, whenever you're making a ratio of areas, you must square the scale factor. Okay? All right, so let's see what happens here. So I know that 3 squared is 9, so I get 9a equals, and then 1.2 squared times 33 is 47.52. Divide that by 9, and the area of the small figure is 5.28, just inches square inches. So what's our takeaway? Really kind of what I just said a second ago. Whenever you're dealing with the ratio of areas, it's got to be the scale factor squared. Okay? The ratio of the areas equals the scale factor squared. And the scale factor squared, I always think of as a squared to b squared. You can think of it as a over b in a big parentheses with the next one with a 2 on the top. I always think of it as a squared to b squared. All right? Any questions? Then here you go. Page 805, do 1 through 13, 16, 17, 19 through 21, 25, 26, and 30 through 37.